Hello and welcome to our LT Spice Circuit Simulation series. I'm Castillo from ECEA-1-1L and today we're going to create and analyze a biased clipper circuit. So, in order to create that, we will need a diode, two resistors, voltage source, one is AC and the other one is in DC, and it is connected in reverse bias with the diode. We will need a ground and a wire, and, and the value of our resistance will be 1 kilo ohm. The diode that we will use is 1N914, and for our first test we will have 1 volt for our DC bias, and is input sine wave of 10 amplitude and 100 frequency. And for better representation in our graph, we just need to label them. And just a quick check if we are recording. Yes, we are recording. And we click the running man icon. The stop time will be in 20 milliseconds, or that is roughly 2 cycles. And we click on our input, so as you can see, there's a 20 volts peak to peak, 10 on the positive, 10 on the negative. And if we click on the output, so as you can see, during the positive half cycle, the value is clipped at a certain point. So what is that certain point? In order to determine that certain clipping point, we just need to look at our diode and battery right here. So since this is in reverse bias condition, positive, negative, we can just add them up together. So 1 plus 0.7, then that will be the clipping value of our output of our circuit. So as you can see, that is 1.67 or roughly 1.7. So what will happen if the input is greater than 1.7? So as you can see right here, if our input is let's say for example during the positive half cycle, our input is 9.69, because of the diode and the battery, the value is clipped at 1.67 or 1.7. And what will happen if the value is less than 1.7? So it will just follow the rule, the voltage divider principle. So as you can see, the voltage in is multiplied by the equivalent resistance of R1 and R2. So meaning R1 times R2 all over R1 plus R2. So using that, we can say that the output is just half of the input if the voltage does not flow in the diode. So as you can see, let's align them together. And yeah, so as you can see, our input is 1.67, and in the graph, as you can see, following the voltage divider principle, the voltage out is just half of it. So half of it is 836 or 837 millivolts. So what will happen during the negative half cycle? So during the negative half cycle, it will still follow the voltage divider principle. So if we look at our input at, let's say for example, negative 8.85, and we align them together with the voltage output, so as you can see, the voltage output is negative 4.25. So that is roughly half of the input. So let's say we change uh, the voltage bias right here. So let's say let's increase it to 1 volt. So let's say 2 volts. And then we click run again. So as you can see, the voltage is clipped at the different levels. So since we increment this by 1, so looking at our current, so 2 plus 0.7, then that will be the clipping value of our circuit. So that is roughly 2.7. And we again look for our for the uh, what will happen if the input is less than uh, 2.7. So as you can see, the input is roughly half of the output is roughly half of the input. So as you can see, 2.54, half of it is 1.27. And the same thing follows during the negative half cycle. It's just as stated before. The input, let's align them together. The input is negative 9.98 and half of it is roughly 4.99. So again, let's increase it by 3 volts and let's run them again. It will still follow, but this time the clipping value is at what value? Is at 3.63 or roughly 3.7. So it still follows the same rule, but what will happen if we uh, add a bias that is 5 volts? So as you can see, there is there are no clipping that is happening right here, as if the diode is not existing. So as you can see, let's align them together. So oh, so as you can see, the input is 9.94 and the V out is 4.9. So at that time, the if we analyze this one, let's say for example in our positive half cycle, the 10, we have a 10 input in the positive half cycle, and let's just imagine that the diode is not here. So following the voltage divider principle, the output will be half of the input. So if we input at 10, the output will be 5. So if we have a 5 volt battery here, so it's just display that it doesn't clip anymore. So as you can see, there is no clipping that is happening right here, but there is a voltage divider principle that is happening, because since the battery that we added is equal to the circuit, to the output of the circuit, assuming that the diode is not here. So meaning that the bias, in order to clip something in our circuit, we need a battery bias in this circuit that is less than 5 in order to clip something. So let's try for 4 volts. So let's click run. And as you can see, there is a small clipping that is happening right here. So yeah, that's here. There's still a clipping that happening because the voltage that we added as a clipping value, additional clipping value, is not equal or greater than the uh, voltage created by the circuit if the circuit doesn't have a diode. So again, the voltage that we need to add as an additional clipper, as a bias to our clipper, must be less than the uh, the maximum the maximum output of the circuit on the outer. So that's it, but it will still follow. And if we have a 3 volt, so it will still follow uh, the explanation earlier that it during the positive half cycle, if the input is greater than 3.7, it will be clipped at 3.7. if the input is less than or equal to the 3.7, the output will be half of it. So yeah, that's it. So 1.4, half of it is 7.37 milliwatts. So that's it. Thank you for watching. Again, this is Castillo from ECEA-B2, and thank you for watching.